So you will end up with 60 minus 25. This will be 35 is equal to 100,000. So V1 is equal 100,000 divided by 35, which is 2857. Okay. So now, so that means software A is economical if we do between 0 and 2857 reports. Okay. So if we do less than a 2857 report, we don't need to pay the 300,000. It's cheaper for us to go with software A. Okay. Now let's see between B and C. What are our choices? We do the same thing. I take 300 plus 25 V2 is equal to 400 fixed cost times 10 V2. Same thing, I take the 300 to the other side and I bring the 10 V2 to here. So I will end up with 15 V2 is equal to 100,000. 100,000 divided by 15, it should be equal 6,666. Okay. So that means if I need between 2857 and 6,666, I select B here, A here, so, and B here, and if I need above 6,666, I go with software C. Okay, that was called the crossover method. Okay, let's look at it here. Any questions?
No question.
No questions.
No questions. Okay, let's look here at A and B and C. So we see we have here 200,000, 300,000, and 400,000. So if we have low volume, we go with A. If we have, as we mentioned, 2857 and less than 6,000, we go with B. And if we have high volume, so we go with C. Okay. Focused processes. Focus brings efficiency. Focus on depth of product line rather than breadth. Focus you can focus on customers or products, service, or technology. Okay. Sometimes you hear, oh, business X or company X is customer focus or product focus or service focus or technology focus, you know. Decision can be complex as other methods may be available. Important factors, of course, these are very important. Cost, cost, quality. So if you are making products or you provide a service with high price, even if the quality is good, so you'll attract some customers, but not too many. Okay. Flexibility, market stability. Okay. These factors decide your decisions. Flexibility is the ability to respond with little penalty in time, cost, or customer value. Maybe competitive advantage, maybe difficult and expensive. Okay, that's what we mean with flexibility. Okay. Process analysis and design is the process designed to achieve competitive advantage. Thus, the process eliminates steps. You know, it's a long process, like the design process. It's a long process. Here, we just need to just understand the process, what is meant by the design process. You know, when they come up with a new idea or a new service or a new equipment or product, it begins with an idea, and then this idea may be based on the customer survey or customer need, and then it comes up, or the market need sometimes, and then it be converted to a design prototype, and they introduce it to the market. Some they succeed, some they fail. It depends, you know. Does the process to maximize customer value? Will the process win order? You know, there are like many examples there for very successful products and some failed products, you know. Process analysis and design. Flow chart shows the movement of material, time function. See, for example, baseline time function, order product, process order, weight, print weight. You know, this is the flow chart with time. And there is something called value stream map, which also shows the process chart. Value stream mapping is like it's a topic by itself, you know. I took a whole class, and I used to teach what we call VSM class. You know, I took a whole class. It's all about value stream mapping. It's very important. You map actually all the processes in your product or service with time. You have time for each process. Why would this useful? This is useful because you need to know the waiting time between processes here. Okay. And then at the end, you will have, we are not covering that here, but just telling you what's the value stream mapping. At the end, you have something called a value added to non-value added activity. Okay. So for example, when you drive from home to school, if the distance 20 miles, usually it should take 20 minutes. Okay. But sometimes it takes, so these 20 minutes you are driving at 65 miles per hour. So these are useful times. So your car is running and burning gas, but it's driving. But when you have like stops for traffic, another 45 minutes. So this is non-value added time. This is waste. Okay. The same thing we do here in manufacturing or service. Okay, so sometimes it's not necessary in manufacturing, you know, sometimes you make a phone call, you ask for something for service provider or to make an appointment, and you wait like 10-15 minutes on the line. That's wastes also. Okay. Begins with symbols for customer, supplier, and production to ensure big picture. Enter the customer order, calculate the daily production requirement, enter the outbound shipping requirement and delivery, determine inbound shipping and method of delivery frequency. As I mentioned, add the process step, machine in sequence, add communication method. It's a comprehensive. Let me see if we have, yeah, we have one here. This is how the value stream map looks like. You see here, there is a waiting time, 5 days here. And then this is a process time for the machine. It's 45 seconds. Just you wait 5 days to be processed, 45 seconds. And then you wait another 3 days for the next operation. 6 days. You see those days, 5, 3, okay, 8, plus 6, 14, 18, 22, 26. That's what we call the non-value added time. Again, this is the non-value added time. Okay. The value added is 1/42. This is non-value added. The value added is 1/40 seconds. Okay. What is the percentage of value added to non-value added? So these are in days. So I said value added, we have 1/40 seconds divided by the non-value added, we have 26 days times 24 hour per day. Okay, now you converted this to hours, and then you convert the hours to minutes. How many minutes per hour? 60, right? This is, let me put hour minutes per hour, and then times 60 seconds per minute. So this will go with this will go with this. You will end up with how many seconds? So let's calculate the value added to non-value added. We have 140 divided by 26. Let me use Excel here. I will open Excel sheet. I want to show you the meaning of that. We take this, put it here in Excel. So we have value added time 140. Of course, it's in seconds. I put seconds here to make sure that I have the non-value added time. It's 26 days. This in days. I need to convert this to seconds, multiply it by 24 hours, then convert it to minutes, then convert it to seconds, right? So now I put here value added to non-value added ratio. This is called value added to non-value added ratio. Okay, so this is equal to this divided by this. Okay, usually it's here it's given as 0.0006, but usually it's 1 over something. So I divide this by 140. That's, so let me say this divided by 140. So my answer would be 1 over 16,000. Let's round 46. Okay, so 1 over 16,046. Let me put this here. So this divided by 140 and this whole number divided by 140, it will give 16,046. So for each second, which is value added, there is 16,046 non-value added. Wow, that's too much. That's too much. So that means that's your job. So why we do that? So usually when we have this, that means that's we are losing lots of time. And you know, it's not just time. You have people are working, you pay them money, you have facility which is cooled and heated, you have machines are running, so you are losing lots. So let's see, I remember the average value added to non-value added for the US was, I think, 1 to 70. Let's see how much it is now. What is the average of value added to non-value added time for USA industry? I remember it's 1 for 70 something, 1 to 70 something. There's no single average, but you know, some they give. Oh, that's not true. It's not 50%. That's why. Oh, this is reducing. Oh, I remember the average. It's yeah, they say percent. No, percent, it's not. We're using one. Okay, so this process is very bad. We need to improve it because there's no specific study, but I remember we have a number, but you cannot, as I mentioned, there are like many processes, many manufacturing facilities and services, but this number is very bad. That means for each second which has a value, you produce something, you have 16,000 seconds waiting and wasting. Okay, that's the meaning of that. I forgot here. Uh, Production 5 needed. So monthly forecast is 11,000. So 500 per day. So 22 work days per month. So this information should be given. Okay. So see here, they are shipping 500 units every day. This is from here. Okay. Service blueprinting focuses on customer and providers, defines three levels of interaction. Each has different management and different potential failure points. Yeah, you study all the processes and you try to find out. Um, yeah, I forgot to tell you that before we used to send students to do their projects in local industries. And most of, we ask the local industries, we contact like 6 or 7 of them and we ask them, oh, do you have a problem for the students to solve? Most of them, they say, okay, can be like, of course, they have their own team, but also when they have somebody else do the work and they compare their results, it's beneficial for them. So most of them, they ask for value stream map. They said, oh, we have process. The value added to non-value added is very small. So can your student just map the process for us and find like a solution for that cut time or something like this? That's what most of them are asking. This is what's called a service blueprint. You know, in this chart here, you see we have, oh, we know what's Pocoyoke, view and complete, delivered, service strategies. These are special consideration with customers necessary. You have to be, of course, interact with your customer. The better these interactions are accommodated in the process design, the more efficient and effective the process. Service process matrix, they call it service process matrix, degree of customization, low and high, degree of labor, low and high. This is for commercial banking, private banking, more professional service. So the more you go up to the right is higher. If there are like 4 quadrants here. Mass service and professional labor involvement, focus on human resources, of course. The rest of the slides, here I see some examples and techniques for improving service productivity. Technique structuring service so customer must go where the service is offered. Example, here we have bank customer go to the manager to open a new. Yeah, sometimes you go to banks, you don't know where to go. There's no instruction, so there should be instruction. Self-service, so customer examine, compare, and evaluate their own. Supermarkets and department stores, internet ordering. Focused restricting the offering, limit menu restaurant. Yeah, these are examples of improving the service productivity. Automation, separation service that may lend themselves to some type of automation. The training, of course, everywhere it's important. Machine technology, oh, that's new machines. Okay, so in machines, I have some experience with machines. So before, we used to have traditional or manual machines, and then they changed to numerical control machines, and then they changed to computerized. The CNC is computerized and numerical control. So what you do in this, I used to teach this stuff. So we used to design something using AutoCAD or Autodesk or SolidWorks. These are like software applications, 3D modeling software applications. And then we take the design and CD or and put this flash drive or whatever you have on the machine and run the machine. The machine will read the design. That's what CNC machine. They have now machine center. Okay. And they then lately added, the 3D printers and additive manufacturing, like the traditional machining. For example, if I want to make a circular part from this, what should I do? I should take it after manually, for example, or using CNC machine and put it on a lathe machine, lathe machine, and take some parts here around here. It will rotate, and then you have a removed material. Removed material. This removed material, even usually scrapped or recycled, but even if you recycle it, it costs money, especially when you are dealing with very expensive materials like titanium, for example. I did one study about titanium removed material, and this costs lots of stuff. You are dealing with removed material. You need space, you need transportation, you need energy to remove this, right? But additive manufacturing, you are adding. So you already have the design for this. So the machine will add material to make it. Okay, so this will add material to make this part. So you are not removing anything. Okay, that will save time, money, and this requires lubrication, and it's too much expensive. So additive manufacturers produce products by adding material, not removing it. That's the idea here. And this will reduce the environmental impact, of course, and supports innovation, product design, minimal custom tooling. You don't need too many tools, minimal assembly time, low inventory, and reduced time to market. That's uh, what they are considered here, the benefits of additive manufacturing. They are building homes with 3D printers. Let me show you if I see the example here. Uh, I saw many. This is not new, building homes using three. It's like this 3D. Look, it's old. That's no look. See, it's robot print. It's 3D printed. Yeah, I know it's in Texas. Yeah, they are building homes. They are building also bridges. The same technique they are building. Look how see concrete build 3D printers. So things are changing very fast. See, automatic identification system (AIS) and RFID improve data acquisition, reduce data entry errors, increase speed, increase scope of barcodes. We read barcodes now. All these techniques are used. Process control, real-time monitoring of control. Yeah, sensors collecting data. So here in our industry assessment center, uh, we have IAC center here, industry assessment center. This center is in the pre-engineering department. We bought last year a whole set of equipment, wireless, okay, to collect data. So you can collect data from machines, you plug it in, and I sit here in my office and the the machine is in another state or somewhere else, and I can not control, like analyze the data. I receive the data. The device is plugged in the machine, and it sends the data to another device connected to the internet, and the other device connected to the internet, and I can log in and see all the data. Okay, measure transit digital signal then sent to computer. As I mentioned, computer program analyze the data resulting out. It may be taken. Yeah, you don't have to go collect the data. Nobody. And this is very useful, mm, actually, if you are collecting data, for example, from the desert or from somewhere for weather data, for example, or something. It's very useful. Particular aid inspection and never board vision system, robots. Oh, we talked about robot perform. Uh, Now like most of the industrial facilities, even they are automated or they have automated some of their processes, because these robots perform tasks requiring significant strength or endurance, generally enhance consistency and accuracy. They are more accurate than human, especially for repetitive. And I think we showed a video last week for automation. Everywhere, they are everywhere. Automation, we talked about automation last time. So we are here, CIM, computer integrated manufacturing, backward. Yeah, they call it reverse engineering. If you have a part you want, we did that before. There are like some machines. If I have a specific part, so it take images for this part, and then it converts this to a drawing, and then you can make it again.